And recording has started. Ricardo, it's all yours.
All right, thank you. So I am Ricardo Guimarães. I am a software engineer, sorry, at Zivid, and I'm going to present the Pulp deployments that we have, which is a very small scale deployment, I have to say, but it led us to some very interesting challenges when deploying Pulp. Right. So let's get to it. But before I proceed, why Quadlets? Why you should be interested in Quadlets? Uh, well, Quadlets can bring a lot of benefits if you want to use Podman, especially if you are already familiar with systemd. Basically, what Quadlets do is to integrate these two systems in a very elegant way. And as I'm going to try to show you guys, the idea is that you can get a very simple and very elegant deployment of Podman containers, in this case, running Pulp, using this technology. So I'm going to go over some context, give more reasons why we follow this path here. Talk a little bit about the deployment itself. Show a little bit of a conversion from a deployment we had before to this new deployment. Talk about some issues we found along the way, and then give some concluding remarks. So, Pulp at Zivid. So I imagine that many of you have heard of 3D printers, but there are also 3D cameras, which are used in a range of applications in industry and warehousing. And Zivid produces these 3D cameras and also the software that's used to work with these cameras. So we have about 50 engineers using the infrastructure regularly, and a few CI runners. And all of these use Pulp in one way or another. We use it mostly to have mirrors of third-party services to reduce flakiness and increase CI speed overall, and also to host our own internal packages for internal development. So we don't use Pulp as a service for the customers, but the infra team inside Zivid, of which I am part, provides services to the developers. And then, since we are a small deployment, we started really small. We started with just a Docker Compose setup on a single host. This is the diagram that I had in mind when I deployed Pulp. Essentially, I'm going to have a bunch of containers depending on each other, and then have some service that might be external. In this case, I just used the Docker Compose setup as well for both Postgres and for Redis as well. And this worked very well. The deployment was quite manual at the time, just a bunch of bash scripts and readmes, but it worked well for a while. But then we saw that we had more tests and we had more workload on CI, also for an increased number of developers. So we needed to scale some of our services. So we acquired a few server machines, 2 to be specific, and we want to have some sort of high availability so that we can safely do upgrades without incurring too much downtime, and also, of course, support the new load on CI. Then we had a few alternatives. We could just try to do everything with Compose, and that's the first path that I took when trying to do this scaling procedure. The problem is that Docker Compose and Podman Compose were lacking some features that I needed to manage the host names. And I'm going to explain why that's important very soon. And also, we already had set up NFS server with replication using the RBD, for those who are familiar with that. And we didn't want to use no root squash or give permissions to every user on the NFS export. We want to have some level of security to prevent some app going awry in the network from changing files on the NFS export. And we were not able to do that, or at least it seemed very complicated to do that using the compose approach. The others supported, let's say, or when you go on the Pulp documentation, one of the other support deployments is using Kubernetes, but it seemed to be a little bit overkill because we literally just want to have 2, maybe 3 Pulp nodes, and we didn't have that much server hardware in-house just yet. So we kind of try to avoid Kubernetes for the time being. It would be, of course, a possibility, but then we tried to do something that was more tailored to our needs. And then I was looking Podman versions, seeing the changelog, and then there was Podman, I think, from 4 onwards. You had this Quadlets feature, and also not too long ago, the Quadlets repo was merged into Podman itself. And then we had already this familiarity with systemd. We use it daily, essentially. And it seemed to be a good middle ground between the features that Compose has and also the features that we would get with Kubernetes. And it seemed to be a good way, or it proved to be a good way to achieve a safe NFS setup, meaning that we didn't have to use no root squash or give full permissions to every user. Oh, sorry, let's go forward. But then what are Quadlets, for those who are not familiar? Essentially, these are templates for systemd services or other files. So here on the right, there is a very small example of running the Podman Hello World container as a one-shot systemd service. You can recognize some sections that are quite similar to normal systemd services, such as the unit, service, and install. But then, among other things, you have this container section here. And the file is also named .container, indicating that this is a Quadlet file that a systemd generator, which comes together with Podman, will convert later on into a systemd service that's going to call Podman with all the required arguments that you need, as well as with the configuration that we specify. So the nice thing that I find about this is that you still have this declarative configuration. It's very readable, at least for me it is, since systemd is something that we work with essentially every day. And you can still see very clearly what you're going to get in the end. So there isn't that much magic behind. It's just basically a generator. And then this is basically how our deployment works now. We are also, of course, trying to adopt more principles of infrastructure as code as we proceed. So we are essentially reducing manual work and working around some potential human errors that can happen during deployment. So we start all the way with some Jinja 2 templates in Ansible, and I will also go into some details on why we are using those. Then we instantiate with Ansible, getting some Quadlet files that the Quadlet systemd generator converts into a systemd unit file. And then systemd itself convert that to a service that calls Podman. So there are many layers here. This may sound quite complex, but in the end, all these layers make our work or made our work much easier. Okay, let's go here. So this is the overall architecture of our deployment. We literally have 2 Pulp nodes. We have some external services, including a load balancer that we use to redirect requests on one node or the other. We have an NFS server, which is replicated, where we are storing the binaries or the packages. We have the Postgres clusterized with Patroni, and we are also using Valkey, which might be a surprise if nobody tried. It has been working very well for us. No difference from using Redis. And inside each node, we have essentially the same setup. We have a bunch of containers that are essentially systemd services replicating the same design as we had with Docker Compose. And then I'm going to show a little bit of the files that we have, that are implementing this deployment. So now we are going to go over a few Quadlet files. So please bear with me. So this one was very interesting, something that we had to do to work around some issues is to create a network. So you can create a Quadlet file to specify a Podman network, well, a network where all your Podman containers are going to communicate. And you can specify that as a systemd service. So you're going to have a service, and in this case here, just to specify the network. So you can specify the type, you can add the network name. Nice. So you can have a network. But then you have to connect things to the network, in this case, the containers. And what I'm going to show you, I think my presentation is a bit misaligned, which is a bit annoying. So I'm going to leave it like this. Is the conversion of the entry for Pulp API in the Docker Compose setup. You can check that on the Pulp OCI images repository, if you will. With, of course, some adaptations. I added, for instance, change the number of replicas and some resources as well. But essentially, here in the first part, you have the specification of service dependencies in the Docker Compose file, as well as declaration of some deployment parameters, such as number of replicas, how many CPUs the process can use, maximum amount of memory, and so on. And of course, you can replicate this via systemd. And interestingly, there is nothing special here from Quadlets. It's essentially just systemd properties which we can set on any service. So here we just declare description, and here there is a hint, right, for those who know systemd, that we are going to use this as a template unit, meaning that with a single unit file, or in this case, Quadlet file, you can instantiate multiple instances of the same service. So here we have the dependency on a target. This is a spoiler for something that's going to come at the end of this section. It can indicate when this Quadlet, what this Quadlet depends on, by after and requires, as usual. So no secrets in here, or not much magic. And then if you proceed, here it's going to look like the Quadlet setup is much more verbose, but that is mostly because I also added a bunch of stuff. So here in the Docker Compose, you just declare the entry point, host name, and the user that this should run as, and also, of course, the image that you're using. So here you can see that at the time we are using Pulp 3.69. Now we are using 3.90, probably going to upgrade again soon to stay on top of the new changes. But here again, we have the entry point as an exec. We have the user, for those who are familiar, 700, the default PID for the Pulp user. We set the host name, and here we have something extra that I'm going to talk about later. And then I also configured the driver so that we can have some nice logging on the systemctl, or journalctl, sorry. And also some tricks to manipulate the UID and GID to make sure that there is no relabeling when we mount the NFS export inside the Podman container, and also to avoid some other quirks that we had with permissions. And then I added some Python path. This is for our DB router that we mount inside the Podman containers. And then we label the connections. This was super useful when debugging database connections. So when you query the connections in your Postgres instance to know which container is actually connecting, which one is not, can be quite useful. And then here on the last line, we have here the network setup. where we can not only indicate that we want to connect to a network, we can also alias the host name of the container inside that network. And this helps when we are setting up Pulp Web, because then we can just say, oh, take Pulp API with the host name. Don't need to care about the index that's going to be replaced here in the %i. And just to finish off, this one is basically translate one by one. You have the health check commands or parameters that you can configure here. They're all here present with Quadlets, the two inside the container section. And then we also have the volumes. And here we're using bind mounts. We try to use the NFS driver, but again, due to permissions issues, and in particular root escalation, not escalation, but common trying to act as root. It was much easier in the end to just use bind mounts. And then this is how we wrap everything together. Because if you had a bunch of systemd services, it would be very boring to just do systemctl start pulp-api -1 pulp-api and so on and so forth with everything. So you can just create a systemd target, add all your wants, add your afters and requires to make sure that when the service starts and when the service stops, everything goes up and down exactly as planned. So here again, this is just a target. This is not even Quadlets. It's just a very nice way to wrap everything up. And then now, the result was quite neat, in my opinion, at least. But then we found some blockers when trying to develop this approach. One of them was in an older version of Pulp, and maybe this relates to the improvements on the tasking system. Because before, there was kind of some restriction. There were some locks in the database that are essentially named hostname at PID, and then that was blocking when you have multiple nodes, especially for Pulp worker that does an exec when it starts, so it gets PID 1. So we experienced some strange issues with a lot of with these conflicts of database lock. But then this was solved. And thankfully, this was only 3 days after I faced the issue, so it was super timely for me. However, the combination of hostname and PID is still used on temporary directory names and maybe elsewhere. So we use templating again. That's why I have so many layers of templating, because they help us to avoid some issues in a very neat way. So in this case, what we did, just add the VM. Well, Pulp is running inside VMs here. And we just add the host name. And then on the Nginx configuration, we make sure that in the Ginger2 template that Ansible uses, we just replace the host name, and then everything is sorted out. Together, of course, with the network name manipulation that we also do on the Quadlet side. So this is a Ginger2 of a Quadlet file, and then we get the replacement in here. We also had a few problems with permissions and ownership. But then essentially what we did is ensure that everywhere we have a Pulp user, you are going to have the same PID and GID. And then you can have a very restrictive permission for others and a very lenient permission for the Pulp user and Pulp group. That's basically the bottom line. In addition, to prevent some relabeling issues with SE Linux, make sure that the context is correct, so you can use historicon for that, and also create a few directories beforehand, just to be sure. These directories will live inside the NFS export. So they should be created before Pulp starts. And then again, this is basically just a happy event, let's say, of this deployment. Configuring the primary and replica routers was super easy because Pulp is behind everything, a Django app. So it was super easy. I was expecting to waste a lot of time trying to tweak things, but no, it was straightforward. I just wrote the router, middleware, and then everything was fine. Just doing the standard thing, send the writes to the primary, send reads to the replica, and then pinning reads on the primary for a while after every write. And we didn't have any issues. It's running now. It's running a bunch of tests every day to make sure it works. And now for some concluding remarks. So at least to our scale, Quadlets are a viable solution for deploying Pulp, especially because we can employ knowledge that we already have in-house, in this case via systemd. It's generators almost all the way down, like 3 or 4 layers of the generators, but this can help a lot and can help simplify things in the end. And it was very good to see that Pulp's design makes the nodes quite independent. So thank you very much. Pulp is a great tool. I love work with it. Thank you. And now, I think it's time for questions.
Go ahead, Deco. You muted?
Sorry,
Deco,
folks,
you're...
I was muted here.
There we go.
Yeah. Thanks for the presentation, Ricardo. It was really good, like, and it's really, I believe, like, the right word to say, I'm grateful, like, to see Pulp on very different places and uses. And I want to ask you, like, 2 questions. First, do you had any issue with, specifically for the NFS part, like I know that NFS 3, it's, I would say, like, it's very prone to some errors, like where we got like a zombie process, like where it's not possible to access the server anymore, and your connection was kept on this zombie. It's really like a zombie state, like where you can't access your files anymore. And like with those containers, like it would be easier, like if you just kill them and start them again, and like to restart the connection. But I just want to know, like, if you had any issue with that. And second thing is, have you tried to use maybe some sort of like S3 service, just like Minio, like to store Pulp objects and so on? And again, man, thanks so much for the presentation. It was really, really good.
Yeah, thank you for the questions and the comments. But we had an idea of using an S3. We have we have some knowledge of Minio, which we could use. However, the thing is that we also want to use the NFS server for Artifactory Community Edition, which doesn't have support for S3. So we want to kind of centralize everything so that we don't have to handle too many services doing a backup, because the main complexity of the setup is doing the backups in a consistent way, because we have to have the Postgres backup, the NFS backup, and also the Pulp itself would like to have the backup, even though it stores data mostly on the other services. And regarding zombie processes, we didn't identify any zombie processes. It might be because of our usage pattern, where we have spikes during the weekend when we do the syncs from large repos, and then we have mostly consumption of these packages throughout the week. But we didn't find any issues with that up to this point.
Nice, man. Nice. Thank you so much for sharing those things.
Outstanding. Ruben, what's your question?
Hi. First of all, thank you for the talk. I would like to be interested. You said that this is a small scale deployment. I would want to ask, do you have any raw numbers on that? So, for example, how big is the deployment? I mean, the amount of nodes you already shared.
Yeah, so right now, I think we only have 2 virtual machines running on Proxmox. Each of them has around 6 Podman API containers, a similar number of contents. I changed this a while ago, so it's hard to recall. And also, I think that each has 3 workers. So it's really a small deployment, because again, we usually have these spikes of usage during the weekend where we sync Ubuntu repos of different distributions, LLVM, and all that. But it has been working for us. But of course, as our scale increases, we are going to be monitoring usage more closely to see if we need to switch to some other approach.
Yeah, that makes sense. Thanks for your answer.
Yeah,
All
thank you.
right. We've got time for one more question, and Dennis, looks like you're it.
Yeah, thank you for sharing this. And my question is regarding documentation. Are these systemd file examples in Pulp documentation? And if not, would you consider contributing just a little bit just to show other users of these examples? Because this is really great.
Okay, yes, sure. I'm completely open to contributing these examples, polishing them a bit as well. So yeah, I hope that potentially Q1 next year to make a PR for both documentation with this description.
Awesome. We would greatly appreciate it. And the rest of the community would appreciate it.
Absolutely. Good, really good point, Dennis. And Ricardo, thank you so much for graciously saying, sure, I'll contribute a PR. Love it.
Yeah.
And like don't
pleasure.
don't overthink it. Like take your systemd files, feed them to whatever AI you use, and have it help you make a PR.
All right. I'll do that.
All right, Ricardo, thank you so much. We are a little bit past time here. I'm going to end the recording. Hang on just a moment here.